Alright, we're going to look at another distribution here, and what I'll do is I'll pull it out here. It's called the geometric distribution, and so it's a discrete probability distribution that has some certain conditions on it. A trial is repeated until a success occurs. The repeated trials are independent of each other, and the probability of success P is constant for each trial. The random variable x represents the number of the trial in which the first success occurs. So what I'll do is we'll come over here and we'll rewrite this a bit. But what I want to do is compare it to our friend the binomial distribution, which we just did. So first, let me get there we go. The probability of the xth trial being the first success in a geometric distribution is PQ to the x minus 1. Well, let's look at this from the viewpoint of the binomial distribution. So the binomial, I'll put a B here for binomial, and I'll put a G here for geometric. So we can see that these are two different things. And so what we said was that this was the number of trials, choose how many you wanted to be correct, times P to the x, Q to the n minus x. Well, let's think about the geometric in terms of binomial. So in the geometric, you're going to repeat until you get your first success. And so no matter how many ways you can do it, let's say the first success is on the 5th trial, you're going to get failure, 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 success. If your success is on the 3rd trial, you're going to get failure, failure, success. There's no combination other than the one correct way to get it. So the NCX just becomes the number 1. And the number of successful trials you have is only the 1. So that becomes P to the first. Now, the number of failures is however many trials you had that less than the one you're on. So here, notice there's 2 failures. Here, there's 4. Or in this case, it's n minus 1. And this gives us the same thing as the geometric distribution. In fact, the geometric distribution is a special case of the binomial. It's a binomial with the number of trials are now your variable. And so in the geometric, we're saying, what is the chance that the 20th trial is the first success? Or what is the chance that the 5th trial is the first success? All right, so we're going to use this particular example from the book. So a study found that smartphones made by a certain manufacturer had a failure rate of 43%. 4 smartphones made by this manufacturer selected at random. Find the probability that the 4th smartphone is the first one to have a failure. Now, what you will find is geometric distributions actually get used in quality control a lot. You will count until your number of failures, and you'll kind of use that backwards to figure out what your failure rate is. And so we're going to learn it forwards right now. Later on, we'll learn how to use tables to do these things backwards. But so let's set this up that we have a 43% failure rate, and we want to find that the 4th smartphone is the first one to have a failure. Well, this brings out a weird thing. I'm going to come here. Right? The success for me and for my trial is the first failure. So notice how it's kind of backwards. So my P is going to be my 0.43, and my Q is the complement. which is equal to 0.57. And so the probability of a geometric distribution that the fourth phone is a failure is going to be 0.43 times 0.57 to the third. Because our geometric distribution is p times q to the x minus 1. There's p, there's q to the x minus 1. And so running over to my calculator here, I'll go turn it back on, 0.43 times q, times 0.57 to the third. And I get a 0.079632999%. Now again, we can go and we can do a geometric distribution here, and our value of p was 0.43, and we were looking for 4 for our x value, and notice we get the same number. And so the geometric distribution is built into our calculator. So to distinguish the two, the binomial distribution gives you the probability when you have exactly a certain amount of successes in a given number of trials. The geometric distribution gives you the probability of success of the first success being a given number of trial. So 963299. And these two distributions make up a very heavily used part of our discrete probability distributions.